Sequences. Well, sequences is a pattern in either numbers or letters. Most of the time in maths, we're going to be looking at patterns in numbers, a sequence of numbers. Another key word we're going to look at is the word term. Each number in the sequence is called a term. So if we look at the first sequence we've got here, this number here is what we call the first term, second term, third term, fourth term, fifth term. And that's really important because when we're looking at the first term, and we're looking at generating a sequence, we're going to substitute the value for the first term as being n equals 1, for the second term n equals 2, third term n equals 3. But the first thing we're asked to do in this question, it says find the next term in these sequences. So how do we get from one number to the next number? So what do you add on to get from 3 to 7? Well, you add on 4. To get from 7 to 11, you add on 4. To get on from 11 to 15, 4. 15 to 19 is 4 again. So we're following the pattern. Add on 4 again would be 23, and the next one would be 27. Likewise, if we look at the second sequence, we've got, you'll notice this time it's going down. So what do you take away to get from 32 to 27? Well, that's 5. From 27 to 22, that's 5. From 22 to 27, that's another 5. And from 17 to 12, that's another 5. So we carry on. We can get 7, then 2. Now these two sequences, this top one is an example of an addition sequence. This one is an example of a subtraction sequence. Where you could have a multiplied sequence. So you could have numbers 4, 8, 16, 32, and what you should notice in this one is it is being doubled each time. So the next one would be 64. Now if you were asked to just describe a sequence, you literally just need to put what you're adding on, subtracting or timesing or dividing to get from one number to the next number. Next skill you need to know to do with sequences is how to find the first 5 terms of a sequence. Now, as I said earlier on, the first number in a sequence is called the first term, second term, third term, fourth term, fifth term. Now, this is the rule for a sequence. It says 3n plus 2. But what is the value of n? Well, n is whatever number in the sequence you're looking for. So if you're looking for the first term, n is 1. If you're looking for the second term, n is 2. Third term, n is 3. Fourth term, n is 4. Fifth term, n is 5. And then we're going to substitute our value into our rule given for the sequence. So 3n, so 3 times 1 plus 2, which is 5. 3 times 2 for the second term plus 2 is 8. For the third term, 3 times 3 plus 2 is 11. For the fourth term, 3 times 4 plus 2 is 14. And for the fifth term, 3 times 5 plus 2 is equal to 17. For example, if you're asked to find a 10th term, you just substitute in 10. So you do 3 times 10, add on 2. Now what do you notice that our sequence is going up in? If you look carefully at these numbers on this side, you should hopefully spot that it's going up in 3s. Now what times table we're using in this question, in our rule here? We're using the 3 times table, and that's what we were going up in. Now that should help us with finding the rule for a sequence. So if we're given a sequence 4, 7, 10, 13, 16, then the first thing that we need to find is what is the common difference between each number. So if we look carefully, this sequence is going up in 3s. Now that means that we're going to be using the 3 times table. Now the 3 times table is 3, 6, 9, 12, 15. And our sequence is 4, 7, 10, 13, 16. Now how do you get from each of these top numbers to the bottom numbers? You add on 1. So what are we going to call this top bit? Well, if we look back at the example we just did to do with finding the terms, it was the number it was going up in was put in front of Vn. Well, that's what we're going to do here. On ours, we're going to put 3n, and then to get from our top to our bottom, we added on 1, so it's 3n, add on 1, and that is the rule for this sequence. 3n plus 1. If we look at a second example, 5, 12, 19, 26 and 33, we should notice that this sequence is going up in sevens. And it's going up in sevens, which means we're going to use the 7 times table. So write down your 7 times table. And remember, we're going to call this 7n. And then what I write down is I always write down what is my sequence underneath. 12, 19, 26, 33. Now how do you get from these top numbers to these bottom numbers? Well, we take away 2. So our rule for this sequence is 7n minus 2. And if you set out your equation every single time like I've just done it when you've got a sequence problem, you shouldn't have any mistakes. But remember, that number that the sequence is going up in is the times table that you're using. And we'll always go in front of that letter n to find the nth term rule.